Okay, so next topic is Venn diagram. Now, in order to express a relationship among sets, we represent them pictorially by the means of a diagram which is known as the Venn diagram. Now, in this diagram, the universal set is basically represented by a rectangular region and the subset by the circles inside the rectangle. We represent disjoint set by two disjoint circles and the intersecting set by the intersecting circles. So let's take an example. Now see, let U be the universal set which is given like 1, 2, 3, 4, 5, 6, 7. And A be the set which is given as 1, 3, 5, 7. Now to represent this in a Venn diagram. See, for the universal set, we make a triangular region. Now this represents a universal set. And the set A, we will draw it in a circular region. This is set A. Now how to write the elements is 1, 3, 5, 7 is in A. This is a universal set and the rest 2, 4, 6 outside the region. Now take another example. Now I'll show you another example. Let the universal set be 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now take A as a set. A will be set A as 1, 3, 4, 5. B as you can take 2, 4, 5, 6. Now, what is A intersection B? A intersection B is 4, 5. 4, 5. So A intersection B is 4, 5. Now, we'll draw the Venn diagram for this. Now this represents the universal set. This is set A and this one is set B. Now see, first of all, what's the intersection point? 4, 5. So 4 and 5 inside this. This is the intersecting point of two circles. Then A is 1, 3, 4, 5. So 1, 3. 1, 3, 4, 5. B is 2, 4, 5 and 6. 2, 4, 5 and 6. Now what is left is 7 and 8. So we write 7 and 8. This is a universal set. Okay. Now next example. U as 1, 2, 3, 4, 5, 6, 7. Okay. You can take A as 1, 3, 5. B as 2, 4. Now as you can see, there is nothing common between A and B. So basically A intersection B will be phi set. Now how to represent this as a Venn diagram? Now again, this is the universal set. So basically this is an example of a disjoint set. You write A and B, two separate circles. This is A, this is B, 1, 3, 5, 2, 4. Now what will be the universal set? What is left is 6, 7. This is the universal set. So this is basically a disjoint set. Okay. Now moving to another example. Now we are taking a situation in which B is actually the subset of A, which is the subset of the universal set, which is the subset of universal set. Now see, U as 1, 2, 3, 4, 5, 6, 7, 8. Set A as 1, 3, 5, 7, and taking B as 3, 7. Now as we can see, B is 3, 7. B is actually the proper subset of A. B is what? The proper subset of A. So basically in this case, since all elements of B are in A. So actually we draw two concentric circles. Smaller one circle represents B, concentric circle or circle having the same center. The bigger one, that will represent A. This is B, this is A, and this is the universal set. So B is 3, 7, A is 1, 5, and the universal set is 2, 4, 6, 8. 2, 4, 6, 8. This is how we make the Venn diagram. That's the theory of Venn diagram. Okay, now when two intersecting subsets of U are given, for representing two intersecting subset A and B of U, we draw two intersecting circles within the rectangle. The common region of these circles represents A intersection B. As I'll show you, on this is a rectangle. This is set A, this one is set B. Now this region is actually A intersection B. This is A intersection B. This will represent A minus B, and this region is represented as B minus A. This is A, this is B, this is the universal set. So this is A intersection B, this is A minus B, this is B minus A. I'll write it a bit clear. A intersection B is represented by this. Now from the Venn diagram, as you can see, it is clear that there are actually formulas. So first formula that we can see from the Venn diagram is, what is this basically? This is actually A. This represents A. So if we write N of A minus B plus N of A intersection B, this will give you N A. Second point, this is N of B minus A plus N, again N of A intersection B, will give you N B. And if you combine them all, you know that this plus this is what? Is A union B. So third point is N of A minus B plus N of A intersection B plus N of B minus A. This will be N of A union B. So these are the formulas that you can memorize and by seeing the diagram. Okay, now there are two more important formulas. See, actually in counting the elements of A union B, suppose we are counting the elements. Actually, A intersection B is counted twice. Once in counting the element of A and second in counting the element of B. So basically, n of the formula becomes n of A union B, that is equals to NA plus NB minus n of A intersection B. So we actually minus one time the intersection one, because that thing is counted twice. And if A intersection B, suppose, is phi, so basically this formula will reduce to n of A union B, that is equals to NA plus n of B. Now if we take 3 set, the formula of n of A union B union C, this will be NA plus NB plus NC plus n of A intersection B intersection C minus, you can keep this in bracket, n of A intersection B plus n of B intersection C plus n of A intersection C. So these are the formulas that we will be using in solving the word problems of the Venn diagram.